Okay, for problem 14, it says, which of the following is a slope field for the differential equation dy dx equaling x over y? And I know slope fields is something that we haven't done a ton of, but they are very simple things. Remember, if you were drawing a slope field, which is not how I'd recommend you go about this problem, but if you were drawing a slope field, then you'd simply pick coordinates of any point on your graph. So let's say you were picking like 5, 5 or something, and then you could just plug in the coordinates at your point into whatever rule they have for the derivative, and then you could plot a little hash line, little kind of dashed piece of a line that represents that slope. So for example, dy dx at the point 5, 5 would be 5 divided by 5. So at 5, 5, you should see something that looks like this little slope that has a slope of 1. Okay, and that was super not going to be my explanation for this problem, but if you notice what just happened, it kind of looks like I just rolled everything out, but E. And the answer is E, so that was kind of quick. So if that's all you needed to hear, then you could stop this video right now. And then there's, of course, a longer explanation that you could do. You could kind of look at, if this was harder than just that, by the way, the answer is E, then you could say, okay, well, what's dy dx, anywhere where x is 0. And so if you were to put a 0 in for x, you'd end up with 0 over y or 0. So if you were looking at that, you could just use process of elimination and eliminate anything where it looks like the little slopey pieces are not horizontal when your x is 0. So all along your y-axis, you should be looking for little horizontal tangent lines. So I'd rule A out based on that because you're looking for, horizontal tangent lines when x is 0. So A's out. B would be out based on that. C it would still be in, D would still be in, and E would still be in. You could also look at dy dx when y is 0. What would that be? It would be a number divided by 0, so you're looking for those to be undefined. So little vertical tangent lines. You could rule C out, I believe, because if you look at the way the pattern is looking, it kind of looks like it's leading into like horizontals on the x-axis. So I feel like you could rule C out that way. But D and E would still be in if this is the kind of thinking that you're using. So you could also then, to decide whether it's D or E, you could look at dy dx in different quadrants. So for example, if xy, your point xy is in quadrant 1, hi sweetie. So if x and y are in quadrant 1, then if you're here, then x and y are both positive. So if you put positive numbers into your derivative function, then your derivative would be positive. And in that sense, you could rule D out because you can see the little slopes of these little marks are negative in quadrant 1. So you could rule D out, and then you'd have option E left. Hope this helps.